Welcome back to the workshop. We want to continue taking a look at functions and definitions related to functions. So we might be familiar with the domain of a function, and that's one of the things that we will consider. But there are some additional terms that we may not be familiar with. So notations as well. So let's take a look at this. Let A and B be sets. To denote a relation f, right? So we've changed our notation already. It went from R to F. To denote a relation f from A to B is a function. Okay, so f is a function. We want to say that. How can we say that? Well, we use the notation f from A to B. And that might be some new notation for you. So f from A to B says this is a function instead of just a relation. And it tells us where the set, what set it's from and what set it's to. But these two sets also have names themselves. So for this function, f from A to B, A is called the domain. And I don't expect that to be anything new to you. And what is B called? I'll let you guess. You're probably wrong, unfortunately. It is not the range. It is actually called the codomain. We'll take a look at the range shortly, because the range does have a very specific purpose and a definition for us. Notice in our definition of function that we don't have to have, right? I could have a C over here in our definition of function. We only need exactly one element in B such that X is related to Y. And it is for each element in A. It doesn't say anything about each element in B. So there could be things over here in the set B that we never consider. And that's why B is called the codomain, because it's the set with which our images or our function values lie within. Okay. But it is not necessarily all of our function values or images. All right, the unique element y in the codomain such that x is related to y is called the image of x under f. Okay, so y is the image of x and is written in the familiar notation of y equals f of x. So y can be represented again by f of x rather than writing y. And that tells us a little bit as well. Y equals f of x is essentially the same way of saying that x is related to y. And in this case, I suppose it would be x f y, because x is related to y through the relation f, because this is relation notation. Okay. And in this case, we've said it's a function, so we introduce function notation as well. All right, so let's take a look at just a couple of examples, a couple of evaluation examples that should be pretty straightforward for us. But before that, just determining if something is a function with the given domain. And again, here, what is important is making sure that the domain, that each element in the domain actually has an image. It needs to be related to some y. All right, so A is the set of Michigan residents, and for each Michigan resident, okay, for each Michigan resident, G of X is the biological mother of X. So the question is two things, right? We have to have that each element of A has an image, and then we also want to make sure that it has exactly one image. Okay, cool. So each person, so maybe, right, we can say each person, but certainly each resident of Michigan. Each resident of Michigan has a biological mother and only one biological mother. If you would like to argue that, that's not an argument for you to have with me, you can go talk to one of the biology professors about a biological mother and how many each person has. All right, but here, yes, definitely. So everybody has one, everybody has exactly one. Yes, it is a function. This is a function. So our domain is the set of Michigan residents, and our codomain is simply people in general, right? Your mother may not be a Michigan resident. That's fine. Okay. We could say the collection of or the codomain is women, right? Because a man can't be your biological mother. All right. So let's consider another example. A is the set of real numbers. And for each real number, right, for each of the real numbers, g of x is equal to log base 2 of x. So is this a function? You want to say yes, and your desire is very understood. But in this case, we would have to say no. So A is the set of real numbers. It doesn't say positive real numbers. It says real numbers. But if you're familiar with the logarithm, right, we have log base 2 of x is equal to y if and only if 2 to the y is equal to x, which means that these numbers, the x's, have to be positive numbers. They can't even be 0. Okay, so negative numbers are not related to anything. So this is not a function. On all real numbers. Now, it is a function on the positive real numbers, but it's not a function on all real numbers. And that's why I include the example, because we want to understand what the significance of a domain is. Okay, this is not a function on the domain of all real numbers. It is a function on the domain of positive real numbers. In fact, it's a function on the domain of positive integers as well. That's absolutely fine. But it has a maximal allowance, right? The positive reals. So I can't say that I can include all reals because that's simply not true. So for many functions that you are already familiar with, they have a domain that's frequently not set. The implied domain is simply whatever you can plug in. And for the logarithm base 2, that's positive real numbers. All right, so let's find the value of f of a. So in this case, we're just trying to make sure that we understand the notation and what the notation is saying. So here, right, f of a is the image of a under f. Okay, that's the language of this class. What we're doing is exactly the same thing that you've done before. F of a is f of, well, a is 8. Okay, no big deal. That's logarithm base 2 of 8. We're familiar with the logarithm. Again, log base 2 of 8 is going to give us the number that, when we raise 2 to that number, we get 8. And that would be 3. All right, we're looking for 2 to the y is equal to 8 in this case to get this number. All right, so the image of 8 is 3. All right, what about this function? So f of a is equal to f of 1/2, which is 4 divided by 1/2. So a nice reminder here, when we divide by a fraction, it's the same as multiplying by the reciprocal. It would be fantastic if you knew why it was, but that I'll leave for you to investigate. So 4 times 2 is 8. Excellent. So the image of 1/2 is 8 under this function. All right. That's all that I wanted to share for now. We'll continue taking a look at more definitions, getting into some that you may not be familiar with. So we'll take a look at some nice imagery, followed by some nice examples to help understand these new definitions. So I'll see you back in the workshop very soon.